4C, which we just did 1 and 4. Now, I'm going to do a little bit of an intro. Was it 1 through 4 or 1 and 4? And 4. Oh, Megadaj, you did more. If I had a gold star, I'd give it to you. But I don't. So, root mean squared. Okay? Root mean squared is not something we're really going to look at, but it's going to evolve into something that we're going to use all the time. So, let's say I had the numbers 1, 4, -5, 3, -7. Okay. And I wanted to tell you about how big those numbers are. Well, if I took the average, then I get -12 and +8. -12 and +8 gives me -4. -4 divided by 5 is 1.2. Is that number good at telling you about how big each of those numbers is? No, not at all. Only one of them is really close to 1.2. So we're going to look at the mean squared, which is basically how, or sorry, what is the name of this? Anyway, the absolute average. I'm going to look at the absolute average. So what's the problem with adding positive numbers and negative numbers together and then taking the average? How come it messes it up? The negatives and the positives kind of cancel each other out, and it makes them seem like they weigh less than they really do. So what I'm going to do now is go through and add them up without the negative. Okay? So I'm going to get rid of the negatives and then add them up. So 5, 10, and 10 is 20. Divide that by 5, and I get 4. And I say those numbers are about 4 units from 0. Is that a better representation than the 1.2? The 1.2 says on average they are 1.2 units from 0. Yeah. This number is way off. Right? There's only one number that's actually closer than 1.2. Does everybody see that? So, to figure out about how far they are from 0, I get rid of the negatives and I recalculate and I say the numbers are about 4 units away from 0. Is that a better measurement? Lots better. Okay? Now, you still don't know why we really care, and that's okay. Just trust me, we do. But we never use the absolute mean squared. And I asked this question to my professor a year ago when I took the class in the summer, and she gave me some fantastic answers that all of a sudden made sense to me, because I've never really understood why we do this tricky way instead of the way that seems to make more sense. And I'll explain that to you when we get there. Okay? But instead of taking the absolute value mean, and I keep saying square, but it's not, it's just the absolute value mean, we do this instead. We keep the negatives, and there are 2 ways to get rid of negatives. One is you take the absolute value, or the other way is to square it. Okay? And if you're smart, you're not going to type in parenthesis -5 parenthesis squared, right? You're just going to type in 5 squared. So I'm going to go through this list, and I'm going to type in, I'm going to figure out what the square is of each of those. So 1 squared is 1, 16, 25, 9, and 49. Why did I do that? It gets rid of the negatives. Okay. Now, let's take the average of these. So I add them together. Oh, this is going to be a little ugly. So that's 41, 42, 50, 1 and 49, 100? Oh, nice. I couldn't do that again if I wanted to. So that equals 100. That's the total. What's the average? Divide that by 5, and I get 20, but 20 is way too big. Why is it too big? Because I squared everything, so I have to undo the squared by taking the square root. And somebody figure out what that is. What is the square root of 20? 4.47? Okay. This is called the root mean squared. Okay. The absolute mean is simply getting rid of the negatives, take the average, and we get the absolute mean. We will never use the absolute mean. Okay? Instead, we are going to use the root mean squared, and you'll notice the root mean squared is larger than the absolute mean. Okay? That will always be the case. It will always be slightly larger. And the fact that it's slightly larger is one of the many reasons why we prefer to use it. Okay? So what I'm saying is these numbers are about 4.5 units away from 0. Does that seem pretty accurate? Yeah. This one is 4, that one is 5, and 3, and 7, and that's 1. So on average, those numbers are about 4.5 units away from 0. Now, which one is more accurate, 4 or 4.5? Well, 4 is the true average. Okay, but when we do that square and the square root trick, it will inflate our average just a little bit, which might seem weird to you, but that's the way we've chosen to do it. Okay, and when we get there, I'll show you a couple of the reasons why that makes more sense. Okay, so with that in mind, we do number 1. So root mean squared, you're going to do 1 squared plus 3 squared plus 5 squared plus 6 squared plus 3 squared. Okay, which gives me 1 plus 9 plus 25 plus 36 plus 9. And what do I do with that list? Divide it by 5. And what do you get when you add that together and divide by 5? 16. And then I take the square root and I get the RMS equals 4. What does this tell me? Those numbers are about 4 units away from 0. Does that look reasonable? Yeah. Most of them are in the 3 to 6 range, and we have one of them that was a 1. If I erase that 1, what's going to happen to my RMS? It's going to go up a little bit. Okay. What if I erase the 6? It's going to go down a little bit. Okay. Which will have more of an effect? Getting rid of the 6 or getting rid of the 1? The 1. How come? It's, oh, good. I like that word, outlier. 1 is further away from the RMS than the 6. So weighing heavy and weighing light kind of have the same effect on the RMS, right? And it all has to do with how far away you are from the center. So 6 is the heaviest number, but it's closer to the RMS than 1. So getting rid of the 1 is actually going to affect things more. Okay, if you do the same for B, what do you get? 10? Do those numbers look about 10 units away from 0? Yeah. Now, if we just took the average would be something like -2. A -2 is a terrible representation of that list. If you took the absolute mean, then you would just change all the negatives to positives and find the average, and that number is going to be smaller than 10. Okay? The RMS is always a little bit bigger than the true average. And number 4, each of the numbers 103, 96, 101, 104 is almost 100, but is off by some amount. Find the RMS size of the amounts off. This is something different. So we have 103, 96, 101, and 104. Those numbers are all close to 100. Did I miss one? No, that's all of them. Okay. They're almost 100. How far off are they from 100? Well, this one is plus 3, right? This one is minus 4, plus 1, and plus 4. Okay? So about how far away are they from 100? Well, what should I do? Should I do 3 plus 4 plus 1 plus 4 over 4? That makes sense to us, right? Yes. This is the absolute mean, and we're never going to use the absolute mean, even though it seems to make more sense in your head. Instead, we're going to use the RMS error. Oh, well, you guys don't know error yet. Anyway, so squared, 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 and squared. 9 plus 16 plus 1 plus 16, 32, 33, 42. What do I do with that number? Divide it by 4, and I get 10.2. Now I have to unsquare it. What is the square root of 10.2? So 3.2. So what does this number tell me? The numbers in the list are about 3.2 units away from the number 100. Does that make sense? Okay, now, if I did it this way, what sort of answer do you think I'm going to get? How would it compare to 3.2? It's going to be a little bit lower.